Big word number one, complementary slash complements. Complementary slash complements. Complementary angles are two angles, only two angles, whose measures add up to 90 degrees. Let's stop right there. What I want you to do is think about a word real quick. What does the word adjacent mean? Raise your hand and tell me what the word adjacent means. Key? Yeah, there's a ray in between. They're right next to each other. Now, I'm going to notice that complementary angle says nothing about them needing to be adjacent. All it says is you need two angles that add up to 90 degrees. That means I can put an angle on the front of this classroom and write 50 degrees on it. Then I can write an angle way in the back of the classroom and put an angle that says 40 degrees on it. And you will say those two angles are complements because they add up to 90 degrees. They have nothing to do with being next to each other. All they have to do is being adding up to 90 degrees. So that's what complements are. So we could say they're complementary angles or they're complements of each other. Each angle is called a complement of the other. The next word we're going to learn is supplement. Supplement is bigger. It's the same thing as a complement. The only difference is now they're going to add up to 180 degrees. Each angle is called a supplement. Each angle is called a supplement. So if this is 130 and 50, they don't need to be next to each other. They're still called a supplement. Be careful on those because I know people on tests are like, well, it's not a complement because they're not right next to each other. They just had to add up to 90 to be a complement. They have to add up to 180 to be a supplement. All right, we're supposed to find the complement of supplement of each of these angles. So they say measure of angle A equals 10 degrees. What would the complement of angle A equals? Yeah, it would equal 80 degrees because 80 plus 10 equals 90. Someone else, what would this? So we have 170 degrees there. Mason and Will can answer the next one. What would the complement of the next one be? Griffin? It'd be 15 degrees. So our complement would be 15. What would our supplement be? Patrick?
105.
105 degrees. Oof. Now we step it up. Now I don't know what the degree is. All it says is that measure of angle A equals y. It still asks for the complement, and it still asks for the supplement. Yeah, if I'm giving a variable, our complement will just be 90 minus y. And I could prove it to you right now. Measure of angle A equaled 10 degrees in the first one. What's 90 minus 10?
80.
Boom. So what's our supplement if it's equal to y? Who got the last one? Jake did the hard one. Yeah.
180 minus y.
180 minus y. Yep, that's perfect. Supplement equals 180 minus y. Because that will actually give you that value. Once we figure out what y is, we can plug it into both those equations and we'll be good. All right, now I said supplementary and complementary. I'm going to say it again. Do not have to be adjacent. Adjacent means they share that ray. They don't need to be. They could be miles apart and they can still be supplementary or complementary. A linear pair is a very specific pair. It does need to be adjacent. So it needs to be two angles that are adjacent. And I'm going to cross out that A. I don't know why I put that in. But they're going to form supplementary angles. Yeah.
Why not complementary as well?
Why not complementary? Because you're going to see. I'm going to show you what these look like. This is a linear pair. A linear pair is basically if you take a straight line and you turn it into two angles. So the important thing about a linear pair is what happens in this case if I add angle 1 to angle 2. What measure does that equal if I add angle 1 to angle 2? Yeah, it's going to equal 180 degrees. So the question was, why not complementary? Because linear, when you see linear pairs, you need to think a straight line and you need to think 180 degrees. So linear pair, what I'm thinking of is 180 degrees. Linear pair, 180 degrees. So that means measure of angle 1, I guess I could put that on there. Measure of angle 1 plus measure of angle 2 must equal 180 degrees, and they must be adjacent. Now let's think real quick on this. What's the only difference between the definition of a supplementary angle and a linear pair? There's actually only one thing different between those two definitions. Massimo?
Supplementary don't have to be adjacent.
Right. Linear pair does. So the only difference between supplementary and linear pair is linear pair has to be adjacent. So you know exactly what the picture looks like. If I say two angles are supplementary, you don't quite know how to draw them because they could be a ways apart. They could be adjacent, but linear pairs have to be adjacent. Linear pairs have to be adjacent and 180 degrees. One more time. Linear pairs have to be adjacent and 180 degrees. All right, our next one is vertical angles. Vertical angles are just basically angles that are across from each other under a specific set of circumstances. And it says it up there. So we have vertical angles are those angles that are across from each other. When two lines intersect. So the other class made a good observation. It's when you see an X. If you can pick out an X. Now note that X might be difficult to pick out because we might have other stuff on here. Don't draw this, but I'm just showing you that later on we might have pictures that look like this. And we got to figure out which ones are forming the direct X's. All right, so across from each other, can someone name a pair of angles they think are vertical in this? Tito? A and B is correct. So A and B, so we can either box those in or you can just throw some circles around them. I'm going to go ahead and circle those two. So angle A and angle B are vertical angles. And we're going to use our notation. I'm going to call that vert, and I'll put my angle symbol on there. Would C and D also be vertical angles?
Yes.
Are they across from each other? On a thing that forms an X?
Yes.
Yes. So those would be vertical angles as well. Maybe I'll box those. Are C and A vertical angles? C and A. Are C and A directly across from each other? They are? Nope, they aren't. You have to be able to draw a line. Basically, they form the same angle. What would C and A equal if I added them together?
180.
They would be 180. What would be another name for two angles that are adjacent and add to 180B? A linear pair. Those are a linear pair. They're not vertical. They are a linear pair. In fact, you're going to know when things are vertical because do you notice something similar about angle C and angle D? They're the same angle. Vertical angles are going to be the same angle, and we'll talk about that in a second. I do want to point something out that won't work. So I'm going to make a little box down here. I'm going to show something that people make mistakes on. I have a little drawing down here. Let's put a 1 here, and we'll put a 2 here. 1 and 2 look like they're across from each other. Why are they not vertical angles? Why are 1 and 2 not vertical angles if they're across from each other? You think you know? Because it's not an x. Remember, it has to be when two lines intersect. This actually has three lines that are intersecting. It has to be that x, like you just said. It has to be two straight lines. Tito? They're always congruent, and that's what we'll talk about in a second. All right. Let's talk about postulates and theorems right now, because I have thrown postulates at you. Postulates are basically things that I tell you that we just need to know are true. They're kind of like, remember those undefined terms that we needed those as our building blocks? Our postulates are going to be kind of our building blocks. So it's going to be a statement accepted as true. A statement accepted as true. Yeah. Yeah. So it's a statement that's accepted as true. A theorem is a statement that needs to be proven. So it's a statement that is proven. So what we typically do is we take postulates. Postulates are kind of like definitions of things. We take those and show that other things are true. Based upon the facts that I give you, we prove things are true. So we're going to move on to something called the vertical angles theorem. The vertical angles theorem. You need to just know this part. I'm going to box in the only part we need to know from this section. Vertical angles are congruent. Everything else we're about to do is from next unit, this proof part. We're going to do an example of this on the bottom. It says example 2. That can be on the test. But this whole thing right here is not on this test. This is actually a pretty advanced thing from unit 2, but I like to show it in class. Because some of us can grasp it and start understanding what our next unit's going to be, and that's proving things. So, I'm telling you right now that vertical angles are congruent. You have to know that for this test. Next test, we're going to prove that that's true. So we're going to quickly prove that it's true in class together. I'm not expecting you to know this for this test. This is for next test. Are we clear on that? Don't want to confuse anyone. Okay. So this says angle 1 and angle 2 are vertical angles. I want to show that they are, in fact, congruent to each other. When you're doing a proof, basically what happens on the left side, we do work. And on the right side, we justify the work that we did. Every proof starts off the same way. I give you something, you have to rewrite it and say, Mr. Pabian gave it to me. So the first step is to restate the given. And the reason why I can do that is because that was given to me. If I gave you a test right now, you should be able to get that right. Gentlemen, put your phones away. That is always how a proof starts. What is given to you, you write given next to it. Now, if I look at 1 and 3, what does 1 and 3 add up to? 180. What does 3 and 2 equal?
180.
Is there something we learned today that said, like, if they form a line like this, they equal 180 degrees? The linear pair postulate. So what happens here is basically you say, oh, okay, I know those are equal because of something I just learned, and that's the linear pair postulate. We just learned that. We said if two angles form a straight line, they equal 180 degrees. That's a rule I have. Then what I said was, well, if they both equal 180, I can do something. I can take this and replace 180 with it. In math, what is that term if you replace something?
Substitution.
Substitution. So we are going to use substitution. And we're going to learn later, it's actually the substitution property of equality. So I'm going to add this po. That can make no sense to you whatsoever right now. That's fine. But you should realize I substituted it. I substituted that in. Then what I did is somehow I got from here to here. Does anyone see how I got from step 3 to 4. A good idea is looking what happened between those two steps. Gianluca?
There's like another way to write it.
There is another way to write it, but specifically, what disappeared?
The 3.
The 3. How'd that 3 disappear? In math, things have to remain balanced, right?
I forgot the symbol, the equal sign with, I'm not sure.
Not quite the equal. Tito?
You just cancel it out.
I just can't. I subtracted it out. I basically took and subtracted measure of angle 3 from both sides. Is it okay as long as I subtract from both sides? Yeah, that's all I did. I subtracted a number from both sides. We're going to learn that's our subtraction.
What is PID?
I'll say it again right now. It is property of equality. Property of equality. So basically, anytime we do algebra stuff like substitution, subtraction, we always add property of equality after, because there's lots of subtraction rules out there. This one is particular to if there's an equal sign. Once again, this is for next unit, right? Yeah. All right, I'm going to move on from this proof because this will not be on the exam or on our unit. But this will be. Example 2 will be. It will give you 2 lines that cross, and they'll ask you to solve these 2 equations. There's actually 2 equations embedded in those. Can someone give me the first one? Yeah, what you got? Mason.
Would be 4x equals 6x minus 26.
Yeah, how'd you come up with that equation?
Just put the,
You got it.
I don't know how to explain it. I chose 2 equations across from each other.
Yeah, vertical angles. He just chose 2 things that are directly across from each other, if they're x's, and he used vertical angles to say they must be equal to each other. What's the second equation we can use? Yeah, Jake.
4x plus 7y.
Ooh, I love that. I want a different one, though. So Jake he's like, oh, these are a linear pair. They equal 180. That would work. That would work once I found y. What if I didn't, or once I find x? What if I just wanted to go straight to y? Yeah.
6y plus 8 equals 7y minus 12.
Yeah. But I just want to point out, if you look at Jake's answer, there's multiple ways to solve these. Jake, yours is only predicated on you finding your x first, and then we can plug it in, and we can get our 180, and we'll get the exact same answers. There's multiple ways to do these. You just have to make sure there's a rule that supports it. Either it's straight across, or it equals 180. I'm going to let you guys practice your algebra on these. I'll give you the answer, if I have the answer still. I think I got y equals 20. And we should come up with x equals 13. So I should see you guys finishing those if you haven't already. As a reminder, our test will be on Thursday. It will just be the Alex portion. That means tomorrow will be a review day. If you look on Alex right now, there's a review assignment that's not graded. I think it specifically says you do not have to do it, something like that. That will not be assigned. But it's probably a good idea that you try those problems because of the problems we did for homeworks. So most likely a lot of them will show up on the test. In fact, tomorrow we'll go through some of them together to make sure we know how to answer them and we know what's going on in those. Any questions on anything we covered?